So my name is Dave Benham. I'm a product manager on the Cisco Wireless team, and I am going to talk to you today about two things that are very near and dear to my heart, AnyLocate and our next generation wireless controllers. All right, so AnyLocate. AnyLocate is our product family for some of our next generation location services features. And I'm going to talk to you about 1.5 of those today. First, I'll talk to you about AP Autolocate, which is our ability to automatically position access points on maps. And I touched on this during the last mobility field day at the end. We've come a long way since then. It's available in all of our platforms soon. Spaces today, Meraki literally next week in beta, and then Catalyst Center coming this summer. The reason we're doing this is to help you, being the partners and the customers, essentially. Save time, save money, make things more accurate, improve troubleshooting. I mean, how many times have you been troubleshooting an issue, looking at which access point a client's connected to, and you have no idea where that AP is?
Did you say next week in Meraki?
In beta, yes.
Okay.
It's in private beta now, public beta next week.
Yep, thanks.
Yep. And we're also doing this to help our customers that have already positioned their APs on maps, but maybe not so accurately. It's human nature when you're dragging thousands of access points on a map that you kind of get complacent after a while, drag them into the middle of the room and think you're good. Well, all of that inaccuracy matters. So if it's really on the outside wall and you drag it to the middle of the room, do that a couple hundred times and your location accuracy is shot. So we can help improve that with this feature. So it's going to help both greenfield and brownfield scenarios. And it also enables some new client technology location that I'll show you. So how does it work? First and foremost, if your access points are GPS capable, it will gather GPS data over a 24-hour period, aggregate it, combine information from multiple APs. So APs on one side of the building and APs on the other side of the building will share their information. And it will use that to help place those APs. The APs that don't have GPS or don't have a GPS signal will use fine timing measurement. Fine timing measurement is a process that we perform on the client serving radio. So we recommend you do this at a maintenance window or an off-peak time. You can schedule it or you can run it immediately if you want. You run this, and prior to it running, it stores all of the AP RF settings. So if you have static channels or auto channels, it remembers where it is, the power, the channel width, so that we can put things back to normal when we're done. Then it disables RRM, so nothing changes during the process and messes it all up. And then it systematically changes the AP channels to a common channel so that they can range with each other. It actually uses a very wide channel as well because we get much better accuracy with that. We use both 5 and 6 gigahertz bands to do this. We don't do 2.4 because we don't get enough benefit from doing that. And the SSIDs and the radios are live at this time, but obviously not going to be a great experience when we're throwing them all in the same channel. So again, maintenance window. Then it stores the measurements. This takes, you could say a minute per AP, but many times it's a lot less than that. It's a sliding scale depending on how many neighbors the access points have. There's a lot of factors at play, as you can imagine. But a minute per AP is a general rule, but a lot of times it's a lot less than that. Stores those settings.
It's Rocky on the bridge.
Yeah.
You may have said it already, but what AP platforms is this supported on?
It's an excellent question.
Do you have to be at 9X?
I have a slide on that, and I'll show you all of the details. The quick answer is most of our Wi-Fi 6 and 6E APs, but I have a specific list on a slide in a little bit that I'll show you. Yes.
Right.
You had mentioned that how many neighbors it sees. What's the blast radius? Is it down to, if I can hear you, at 104 or 95 or 75? Is there some limit?
I don't know that we have a hard limit, but things obviously get worse as the signal gets worse. We jack the APs up to max power, just like RRM does, to measure its distances. So it'll be better than it is during a normal running environment. I don't know what the cutoff is. I can look it up and get back to you, but. So it stores those measurements for future use so that you can actually plot them on a map. And then it returns everything to their previous state. So it goes back to what it stored prior, whatever channel power it was on, whatever mode it was in, as far as it was auto or static, all back to the way it was. And then if RRM was enabled before, it turns it back on for those APs.
Dave, looking at the RF signals received, is it also going to consider the transmit power of the transmitter?
It doesn't need to. It's more about time it takes to get there versus the signal strength. It's not doing an RSSI calculation to determine how far away you are based on how weak the signal is. It's just needs to get a signal. So it needs to very accurately time the signal between the two APs and the ranging exercise. And if it gets the signal, it's good. So it shouldn't need to keep track of what the transmit power is on the other side, but it does elevate all the APs to max power during the process. So as part of this process, you need to anchor access points on maps because we have to know where things are relative to your floor plans, right? Take some APs, place them in the corners, and the number of APs that you need to place varies based on your shape and size of your floor plan. If you have a huge floor plan with lots of weird nooks and crannies, you're going to need a few more anchors than if you have a rectangle with 10 APs in it. So take that into consideration. And the more accurately you place those anchors, the more accurate the results are. What if I told you that you could also do this without anchors at all? So I'll show you a brief demo. This is about a 1.5-minute video in Spaces. So go down to the device placement. That's a new menu within Spaces. And you'll see a banner at the top saying some APs have moved. Would you like to review them? That's a new feature, by the way. I'm not getting into that right now, but it does notify you if APs move, and you get the opportunity to rerun the process to see where the heck they are. So you pick a floor plan. I messed these APs up on purpose so that we could run the algorithm and see what it looks like, so we don't have APs on the front lawn. You select the APs that you want to participate with. This is auto-clustered by groups of APs, by floor, whatnot. You run it. And this is the, I'll say the post process. This is not the RF measurement process. This is once we have measurements. Now we're putting them on maps. And you'll see a banner pop up saying there's no GPS enabled APs. Basically, it's saying we don't know where any of your APs are. So we're going to give you a constellation of access points. Your AP's on a plane. And you can rotate and zoom and flip that plane to match the shape of your building. So if you have a building shape, and your APs are obviously going to be in the shape of that building, you can zoom, rotate, and just plop the entire constellation onto a map.
And scale.
Yes. Yeah.
That's really how it should be.
Yeah.
Agreed. I pushed pretty hard to get this feature, and it took us a lot of time to figure out how to make the UI intuitive. We're still working through it, but I'm really happy with what we've got because it does allow you to just take the whole thing, drop it in. You don't have to position anchors ahead of time. And if you've got GPS, you don't even have to do this. It just does it for you.
Yeah, that's really neat.
Click a button and it's done. So, as I mentioned at the beginning, this also extends to things other than APs. Find time measurement is not limited to APs. We can do FTM ranging between clients and access points. So today, a lot of traditional Wi-Fi client services, location services, are done by RSSI, or have been for the last 15 years. We can have the client initiate ranging with the APs that it hears and say, hey, how far am I from each of you? And then the client itself can calculate where the heck am I in relation to these APs. Now you're probably thinking, how does it know at all where the APs are? What am I going to do with that information? We can enable optionally LCI or location configuration information in the frames so that the AP can tell the client, here's my geo coordinates. And then the client can say, okay, think of it just like GPS, but not. It can say, okay, I'm this far from each of these APs and I know all their geo coordinates. I'm right here. And it's really good. I mean, it's within a couple, maybe 2-3 meters. It's great for navigating, wayfinding in a building. It works awesome.
You said AnyLocate for the infrastructure is impactful to service. That's because of the channel changes and whatnot.
Correct.
For clients is not impactful?
Well, it's impacting as much as traffic would be.
Okay,
Does
so
not,
no.
does not change the channels. We don't give every client the power to change all of your AP channels.
I didn't realize that the disruption on the infrastructure side was because you're putting everything on one channel, cranking up the power and monkeying with the radio
Correct.
settings.
That's the only reason it's disruptive. And in this case,
Gotcha.
it's just picking the APs that it can hear and individually ranging between them to
Gotcha.
get the distance.
Okay.
And if you did that on 1,000 clients, yes, it would have an impact, just like 1,000 clients doing data would have an impact. Pretty cool.
No doubt.
All right. So, Rocky, here's your slide that shows the specific support on access points down at the bottom there. Supported on all 9800 controllers. Supported Meraki Catalyst very soon, and most of our 6 and 6E access points. Any questions on AutoLocate, AnyLocate? All right, move on to wireless controllers. So I've been doing this a long time, and I recognize how important it is to support and innovate both cloud-based and on-prem customers. And we're proving that by innovating and releasing new wireless controllers. So we've got a whole family, 3 new controllers to show you. And they align like this in our portfolio. So you can clearly see where the new ones are. We have a CW9800M, which is going to succeed the 9840. And we have a CW9800H1 and H2, which will succeed the 80. I will get into the specific details of each. I want to be clear, though, that this is a very much an evolution and not a revolution. This is not an AirOS to 9800 type of change where you're going to have to rethink your design, reconfigure everything, relearn, retrain your staff. Same UI that you're used to, same iOS XE, same config structure, so no dramatic change there. We're just taking what we had and kind of improving on what we had already done pretty well, in my opinion. So the CW9800M, it has up to a 50 gigabit per second backhaul. It supports 25 gig uplinks, 1, 10, and 25 gig uplinks, 32,000 clients, which is the same as the 40, and 3,000 APs, which is a 50% increase over the 40. And personally, coming from partner side not too long ago, I know a lot of customers were kind of in that like 17, 18, 1900 range of APs, and they wanted some more growth. And they would have in the past had to buy a Dash 80. Now they can get that growth this. So this is a real sweet spot for scale, I think, for a lot of our customers. And in addition to beefing up the scale a little bit, we made it a lot faster for real world traffic. So you load this thing down with AVC, QoS, all the bells and whistles turned on. It performs a heck of a lot better than what we've had before, 53% faster on the high end of that. And it does it with less power. So it's more power efficient. That's a big deal for a lot of our customers. A little detail is that it also has a 10 gig HA port. So you might be thinking, why the heck would you ever need 10 gig on your heartbeat interface? And you don't need 10 gig of traffic, but we have customers that have only 10 gig ports and higher in their data centers. So they could not distribute their HA over the network because they had nothing to plug it into. They had to run a really long cable or put them right next to each other. This gives you that flexibility. As silly as 10 gig HA sounds, it's actually really important in a lot of scenarios.
Hey, Dave, is there going to be a premium for these hardware platforms over the ones they're intended to supplant?
The price is 5 or 6% higher. So think of inflation. Not a substantial hike in price, considering the other controllers came out in like 2018.
Yeah.
Not too bad.
The HA port is not just 10 gig only, right? It can
Correct.
negotiate.
So there's 2 ports. There's a copper port and an SFP plus port. The copper port is 1 gig and the SFP plus is 1 or 10 gig. And we can do line rate encryption with hardware offload. So our older controllers did a lot of the encryption in software. This has a hardware capability to do that, which is also a reason that it is faster in a lot of scenarios. The other 2 controllers, the big boys, the CW9800H1 and H2, are very similar to one another. They have more capability, so you can see up to 100 gig per second of backhaul. Each of them has 1/10 gig ports, as well as either a 25 or a 40 gig uplink port. And that's the difference between the H1 and the H2. That's the only difference between the H1 and the H2 are the physical uplink ports. And you might be thinking, well, I had modules before. Why can't we have modules now? Why do I need a different model for the different uplink ports? Take a closer look at those and you'll realize they're 1 RU. Our old 80 was 2 RU. That's another big deal for data centers and efficiency and such. With 1 RU and all the stuff we crammed into these guys, we couldn't fit a module slot. So you get 2 different models and you get to choose between either 25 or 40 gig. Everything else that I talked about, all the features and everything, pretty much the same with these. Same web UI, 10 gig HA, all the other features are the same. This is even more power efficient than its predecessor, though. That's the big difference.
Dave, I actually want to ask a question about those 2 ports.
Yeah.
So one's 25 gig capable, the other one's 40 gig capable. And because there's no modules, is that because the back planes are different in those 2 to accommodate that? Because I know there's not really a lot of compatibility between the 25, 50, 100 gig train and the 40, 100 train.
Mm-hmm.
Is that the difference why there's 2 separate units?
So there's the 2 separate units is because we couldn't fit the modularity in physically into the box. You do probably need a different backplane for the section of 40 gig ports. I don't honestly remember from that phase if that part is different. But we had a lot of customers with 40 gig on the Dash 80 and we wanted to give them an upgrade path.
But I know that a lot of people basically 40 is kind of hitting the end of the road because the 2500, 400 is coming next.
Yep.
Would it be safe to say that in the future the primary development's probably going to be on the 25 train?
Yeah. I mean, 40 is not going anywhere, but like you said, 25, 50, 100 is kind of the direction things are going in. But again, we wanted to give customers that have the 40 gig now a transition path. A simpler transition path. So that's the reason for the 40s.
Awesome. Thank you.
Thank you. So the scale is pretty much the same, 64,000 clients, 6,000 APs, but the big deal here is 1 RU.